There was a time, and it wasn't that long ago, when people would be digging in the hills, maybe putting in a house or a garden, or just playing, moving rocks and dirt, and they would come across something different, something that wasn't rocks or dirt. It was often stuck in the rock and sometimes just laying there by itself. It was hard, usually shiny, and you could work on it without it fragmenting and falling apart like rocks did. Plus, it could be melted and shaped, and there were several different kinds of this stuff. It was metal, usually gold or silver or copper, just lying around or embedded inside of the rocks. This was great stuff and valuable because with it you could make things like tools and knives. Was there more of it? And why was it so different than everything else? These kind of questions and these discoveries were the beginnings of what we call chemistry. Chemistry is often called the central science because it connects all the other natural sciences like astronomy and geology, biology, and physics. So, just what is chemistry? When we think of chemistry, we often picture someone doing this. And in reality, I suspect you will seldom catch a chemist staring into a beaker of colored liquid, except when posing for photographers. And apparently, lots of photographers believe that this is what chemists do because you see lots of these kind of pictures. Technically, chemistry is, quote, the study of matter and energy and the interactions between them. That oddly enough happens to be the same definition for physics, the study of matter and energy and the interactions between them. So, what's the difference between chemistry and physics?
Well, imagine if the universe was this pocket watch. Physics examines the movement of the hands and the springs, the forces that cause it to wind and unwind, the sound of the ticking, the light passing through the face. And what is sound and time and light anyway? Physics is the physical mechanism, the universe, and how it works. Chemistry, on the other hand, disassembles the watch, disassembles the universe into individual components, the minute, the hour, and the second hand, the pieces and the parts. Then the chemist tries to reassemble the pieces to make something new and different. Can we reassemble the pieces to make different watches? Or maybe even something that's not a watch at all, like cufflinks or jewelry or earrings. Or let's take another example, this toy truck. It isn't a single piece of plastic, is it? No, it's made up of several components that were put together to assemble the truck, and it can be disassembled again. For example, here is the bed of the truck, and the cab of the truck, and the frame. And the cab itself can be broken down into smaller components, like here's the light and a little yellow piece, parts that were found in the original toy box. When you finally come to a component that can't be broken down any further, you know you've arrived at a basic toy part, a basic toy element that can't be broken down anymore, unless of course you hit it with a hammer, in which case it ceases to become that toy part. Like, here's a wheel piece, a light, a red brick, and so on. Now that we've got these basic toy elements, we can build completely new things that we couldn't when it was still formed into a truck. For example, we could make a spaceship or a building or a completely different truck. Once you disassemble it, you can make completely new and useful toys. But you have to disassemble it first. The world of chemistry is similar to these toys. We come to things in our world, grass, water, the air, the couch, and we break them down, just like the watch and the truck, separating them into smaller and smaller components until we arrive at the basic parts that built it in the first place. In fact, the motto of early chemists was, in Latin, solve et coagula, separate and join together. Solve et coagula. And that is what chemistry is, the art of separating everything into its individual pieces or elements, then recombining them to form new substances. Now, it is true that much of chemistry can be very complex, requiring a great deal of hard work, years of study, a lot of complicated math, and yes, probably some staring into beakers of colored liquid. But it is also true that a great deal of chemistry can be fun to study and understandable by just about everybody, even if you don't know the complicated math. And that is the area of chemistry that we want to explore. In the first part of Chemistry 101, we will look at the amazing stories of how we started breaking the components down until our journey ultimately arrived at this, the periodic table of the elements. Hopefully you didn't give in to despair when you saw this, because that is a common first reaction. And there's absolutely nothing about the periodic table that says user-friendly on it. In fact, the only thing that most people understand when they first see this table is the word table. But I am certain that by the end of Chemistry 101, you and the periodic table will actually become good friends, that you will understand what it means, how to read it, and even how to explain it to somebody else. Then in the next sections, we'll go a little deeper into the chemical world, even to introduce you into how to balance chemical equations, which look something like, brace yourself, this. 2Mg plus O2 equals 2MgO. Huh? And what in the world do those ball and stick things mean? Well, we'll find out. Then we will take a fascinating tour of every single element on the periodic table. And finally, we will end with the future of chemistry.